or just an idea you had, right? I was confused about the placement of it into the function. Okay. So basically, as it turns out with Riemann sums, what I would probably do is take this function and graph it on Desmos, and then from there, kind of try to see like what the heights of the rectangles would be. So that's a suggestion. Or another suggestion is a tool I can hand you, and you could perhaps use that tool. I think I made it as a comment on, I think I used it on Stormy's copy. So 1 second. So let's see. I know I left it here somewhere. Where's my comment go? It's probably because it's showing up. Okay. There we go. So I have a tool for you that you can use if you're saying you want to use Riemann sums. So I'm going to go ahead and share you the tool. So let me put this into the chat. I mean, what I could do is I could stop and start telling you how to draw rectangles in the function, which would take up a lot of time. So if you click on that link that I just shared with you, you get this. So this is actually a Riemann sums kind of calculator. What you can do is you see here, you could change this to be any function you want. You could type in the e to the x function. And you could also put where you want it to start and where you want it to end. So A is your start. So if we want to start at 0, and I think our B was 1. And then down here, I think N is 12 is the amount of rectangles you want. Not only that, but even down here, it gives you the Riemann estimation of the area. So there is a tool you could use if you want to use Riemann sums for this. Oh, you shared this before. We can use the letters to add more triangles. Rectangles, yes. So for example, let's say, so I don't remember what the function was, but you're just going to put the function here. Let's say I want 100. It's going to actually give me 100 rectangles. And if I scroll down, it gives me the estimate of the area as well. So basically, that's pretty much a tool you can use to make your estimates. Just explain it to us, like what we're doing and why. Like, okay, I'm gonna use this big idea about Riemann sums because, we don't have any rules. Oh, okay, so I can use it for both and explain what I'm doing and why. That's correct. And you can even explain why you chose a certain number for how many rectangles as well. Oh yes, I forgot to let you know, but okay, these are, okay, so it says left. Okay. I was trying to take a look at what kinds of rectangles these are. If these are left or right. Let me just go back. So it looks like if I'm zooming in, these are left hand because the upper left hand corner is touching your curve. I was trying to see if we could switch that. Oh yeah, you can. Take a look here for one. You can make this a left hand if you make C 0. If you want a right hand sum, you make C equal to 1. So I would change this to 1 so it becomes an upper right hand sum. Or 0.5 for the midpoint. A lot of you like that midpoint sum. So you change this to 0.5, there's a midpoint Riemann. So you could totally use this tool to help you out for number 5 and number 6. So let me know if that right there is helpful for you, Juan, to tackle that. Or if you have any other further questions. Because then after you have this tool, I'd like to see what you do with it and what. Okay, perfect. Yay. I'm glad to get you started on that. Okay, awesome. I'm gonna go ahead and work in and check in with the AP Calc on getting started, and I'll be right here. Okay, cool. So let me just move this. So basically, this thing right here for Viviana and Israel, that's gonna be useful for 5 and 6. So if you look at 5 and 6, That's coming in. Okay. So I'm gonna get you all started. So give me a sec. Let me pull up that mini. I could project it. Okay. Did you all read the prompt of like what you're being asked to do? That's right. So we're trying to find the area basically of those shapes is what we're trying to do. Um, is that like pretty clear? Okay, cool. So that's our goal. And if you go to the original document, you see everyone's kind of comments and like, questions and things like that. But basically, for number one, let's see, Israel, I wonder if you have any ideas. How would I find the area for this? So it looks like it's like a square. It's a square. So what's the area of a square? Don't you just square the? Isn't it just times itself? Yeah, something times itself, but what exactly? And I wonder if you, Viviana, can, if you remember. So this one, like right here, or would it be two? Or would it be two, like the length? Are you saying like this? I think it's the width squared, right? The width squared because it's a square. And what's our width? Because basically what we're doing to find the area of a square is base times height. So this is 2, this is 2. That's why 2 squared is going to give you 4. So finding the area, and by the way, if you forget the area of a shape, just Google it, like the area of a square, it's going to tell you base times height. So this right here, if we do 2 times 2, 4 feet squared. That's your area. And all y'all got to do now is just type out or like write out what you did to find that out. And y'all just figured it out right now. So that's just it. Basically, if y'all notice, you don't need calculus here. You just find the area of a square. Then, hi, Rebecca. Yours gonna come back later. Hello, Rebecca. And then let me know when you both are done, and then I'll transition back after y'all write down with how to find the area for number one, and maybe y'all can figure out how to find the area of the diamond-looking shape for number 2. You can do like a square. You can definitely. You can. You just want to figure out. Yeah. Go ahead and try it out. Let me know what y'all get. Okay, Angela, I'm sorry, Rebecca, let's go ahead and let me open up your mini final. So just so you know, I'm gonna be transitioning between 2 things. So I have AP Calc and I also have Pre-Calc. So I'm gonna be transitioning between both. And so I hope you have some patience with me. But let me go ahead and open up your mini file. I know you shared it with me, I think yesterday in the email. Let me go back. And I see AJ there, so I'm gonna open up that. Let me just grab that. It's loading. Okay. Oh wait, what? I thought you shared it with me yesterday. Let me just go to Google Classroom. For which one? So either 4 or what's the other one? Oh, we could try to figure out which one it is. And I could also ask you, whoops, let me see. Because I'm going to open up some mini finals right now, but I could also ask you, does number 2, does the window area look smaller than the area for number 1? Yeah. If it looks smaller, then it should not be 4 because number 1 had an area of 4. That could be another way you could kind of reason with it, but we could also come back and talk about it too. So let's see, let me just open up the mini finals. Okay, there's Rebecca's. And here's Jasmine's as well. And then for AJ right here. I'm gonna also make sure I open, I don't think I see. This for when Dior comes back. See if I can open that. No, I don't think I have her copy, so she'll have to share it. Okay, y'all. So let's go ahead. Let me first give an overview of where everyone's at. So let's see. So Rebecca, I think we left off after number 1 yesterday is where we left off. So number 1 looked good, I remember. Yeah, we did that. You found your frequency and you're starting on number 3. Okay, good. And then for Jasmine, we did number 1 perfectly and we gave a start on number 2. And okay, so you're like halfway done with number 2. And for AJ, let's see where you're at. You got number 1. You got to start on number 2. And you were asking about how to get started with this. Okay. Okay, so let's see. So it looks like let me go ahead and start with, because I know, Jasmine, you're already kind of like midway on number 3. Let me go ahead and start with Rebecca, and then AJ, you can look at how I'm helping Rebecca start on the equation. And that could help you as well for when you're making your Desmos. So let me go ahead and do that. And in order to do that, I need to open up our big ideas packet. So I need to have that resource open. If you don't already, if you could please have that open. Let me just. Okay, so if y'all want to figure it, so are we agreeing that the answer is 2 now, actually? For Israel and Viviana? You got 2. Okay, so yes. Just if you could explain it, that would be awesome.
Just because it's 0.5.
Okay, so just because you saw the 0.5, you kind of just halved it. Interesting. Okay. Oh, 1 times 1 is 1. Okay, that's a good argument too. So we'll have to take a look at it. Big idea. So those 2, by the way, you don't need calculus. Number 3 you will be needing because it's like a curvy looking thing. And we'll talk about that hopefully soon. Okay, so I'm just opening up our big ideas packet. And so once we start for number 3, where you want to go is big idea number 9, how to create sinusoidal modules. So everyone here, make sure you have your big ideas packet open. We're going to talk about how to create sine module. And if you remember, there's a whole process to it. Remember I had to show you and I had to color code all this. That's what we're going to be doing here today. So I'm going to start looking at Rebecca's, and then for AJ, if you could look on and see how we're doing this. This is what we're going to start with. So if you look to big idea number 9, you're going to, oops, that's not my big idea number 9. You're going to notice that I find my A first. So I usually go A, B, C, D. And to find A is also known as your amplitude. Now, if you go a little bit upper, so big idea 9, in the definitions, it says the amplitude is the distance from midline to a peak. And then you're like, okay, what's the midline? Go down to this definition. The midline is that horizontal line that passes in the middle between the wave's maximums and minimum points. So we need the midline to find amplitude, the A term. We need to make sure our A term is perfect, basically. So let me get out of this. I'm going to go back to Rebecca's. And how we're going to find the A term is we need to go back to your original sine wave. Step 1 is you need to draw your midline. The midline is actually right here. So notice how when you use the tool, it actually already finds the midline for you. So what I'm gonna do is I'm just gonna draw a straight line through it so that I could see where the midline is intersecting my y-axis. So this is a question for you, Rebecca. Where is the midline intersecting on the y-axis? It looks like it's between 0 and 0.1. What would you say this intersection point is at? Hey, Jayla. You have at 0.5, so super close. So halfway between, right? 0.5, look at the units though. 0.5, see this is 0.3? 0.5 will be somewhere up here. So you actually want to go a little bit smaller. So the number you're actually looking for is 0.05. So that's actually 0.05. That is actually where your midline is intersecting. Okay, so you found your midline. But remember, according to the definition, to find the amplitude of your wave, let's go back to the definitions. It says it's the distance from the midline to a peak. So a peak. So distance from midline to peak. That's basically this very small green part that I just drew right here. We need to figure out what that distance is. How you can figure it out is you got to actually estimate where that maximum is at. So now there's a new point you got to estimate for me, for Rebecca. So now what is this number? So if we know this is 0.05, then what in the world is this number? It's a little bit less than 0.1, but it's definitely more than 0.05. So I wonder what's an estimate you could give me for this top number here. And that's how we're going to be finding our amplitude, 0.07. I like it. Let's do 0.07. So we got 0.07 as the topmost number. Okay, so we have where the maximum is at. We have where the midline is at. So then what is the distance of this line? I wonder if you have any ideas on what we could do to figure out that distance. So basically, what's the difference between 0.07 and 0.05? That's going to tell us that distance. Let me also just change this to black. So we want to know what is that distance. You put 1. Okay, can you describe how you got 1 there? That for me, that's not a 1 though, that's just me coloring it. But if you want to describe to me how you got the 1, that'll be awesome. Finding C in my mini final, do I use phase shift? And when you finish, can I get help? Yes. Yes, we could talk about phase shift for yours, yes. So a way to help, Rebecca, that I've been, because on my y-axis is 1.1. Oh, okay, you're looking here. This is actually x-axis. So you actually just want to focus on your y-axis when you're trying to figure out what this height is right here. So what helps, I don't know why this always helps, but I like to envision 2 friends. So you have a shorter friend. Let's say their height is 0.05. And then you have a taller friend. And their height is 0.07. Just pretend that this is the case. So, oh yeah, see you, Jayla. It's okay. So then what if I was to ask you, like, how much taller? Okay, you got it. I didn't have to ask you the question. So you knew that you're subtracting the 2 heights. That's how you find the difference in heights, AKA, that's how you're finding your amplitude. You're subtracting your the maximum point from your midline. So for everyone here, you want to double check if you found your amplitude correctly. Subtract the maximum from your midline number. That's correct. So Angela, your amplitude, your A term is going to be 0.02. And that's how you get your A. And then let's see, because I know I'm gonna jump to Jasmine's, and then let me check to see on for AJ. AJ, did that make sense? And I haven't checked your amplitude, but on how we figured out the amplitude, if you want to go back and make sure your amplitude is making sense as well. I could see you got 0.5, but 0.5 is too large for an amplitude. Because remember, like same feedback, 0.5 is like all the way up here. So your amplitude is going to be way smaller. So let me know if you have any questions, AJ, about that. And then, oh wait, let's see, chat. Okay, we got okay, yes, and then we could check in, so we give it a go. And then for Jayla, so let me see, where are you at in your mini fund? Well, not started? Oh, perfect, go ahead and open up a copy, so I know exactly where to tell you to go to. So that way you're not just waiting. Part one. Try part two, whichever is linked up. There's a copy, perfect. This like book thing is not even stable for me to sit on. I know. I'm like, what is the point of this? Random books. Yeah, I have no idea where they came from. I mean, I know the Dr. Stone, I ordered it for the student who liked reading the. Yeah, I know I had a little bit more, but some of these are like, yeah, the unwanteds from the library. A chicken soups are good. I cried before reading those. They have like heartfelt stories. Okay, perfect. So this is what you're gonna do. You're gonna scroll down to number 2. And you're actually gonna click on that highlighted yellow video. And what you're gonna do is you're gonna watch that video. It's gonna help you get started. So you're gonna know what to do after. That's gonna basically me explaining it. So you're gonna watch it, then once you're done, see if you can get started. If not, just ask me questions and I'll help you get started. Perfect. Okay, cool. So then now I could go to Jasmine's question. So I'm going to jump to Jasmine's question. So everyone in this Zoom could fix up your amplitudes. So let me clear this up. And let's jump into Jasmine's mini final. So we're going to talk about your C term. So first, let me say, I forget what we used. Did we use sine or cosine for yours? I don't recall. We found the amplitude. You found, okay, I don't think, maybe we didn't choose. So we could use either sine or cosine. So this is what your wave looks like. It looks like it starts from a minimum and then goes up. So let's see. So in order to figure out phase shift, we have to know sine, like if you're going to use sine or cosine. So this is the difference between sine, cosine. Sine starts from the midline and then goes up. Cosine, though, starts from the maximum on the y-axis and then goes down. But then yours started like at a minimum and then went up. So it's basically up to you because you are going to have a phase shift. Up to you if you want to use sine or cosine as your parent function. You want to use sine? Okay, so we're going to have to find where your wave starts at the midpoint and goes up because that's its starting point. So let me go to your, oops, mini final. So remember when we first drew the midline on your graph, right? It was, I forget where it was. Was it at 0.05? Right here, right? I think so.
Yeah.
Okay, so there's your midline. So remember, sine starts at the midline and then goes up. So that happens right here. Starts at the midline. Oops. Starts at this midline and then goes up. Oh no, what happened? Oh no.
I didn't know I needed to charge it.
Let me delete this. And then we do still need to talk about diamond, right?
I tried to look at, couldn't do anything on
Okay, so I could check in on that one too. So let me let you get yourself set up, Jasmine, and then, let me just check it over here. I wish I had like a moving board or something. Yeah, Power Square.
Don't do the actual.
I'm not looking at the estimate now. I'm curious to see why you chose 0.5 as the radius of the circle. The radius is half of the diameter. Can you point out what the diameter is? That's the diameter? The diameter is actually the line that goes all the way across. So then what would be half of your diameter actually? And then I would 0.8. For which one? I'm not sure if that's something I knew this really did. Oh, okay, what was your R? Oh, I think you're right. R is 15. Oh, okay, but I think you messed up on one of those. Am I supposed to do the R squared? Yes. So I should 3.14. That's right. So that's your area. Yeah, you got it. Though. Your radius was correct. Just make sure when you start typing out your information, just type out 80. Oh, never end up. Perfect. Y'all are moving on to the ones you know how to do. Awesome. Wait, so then how was that one? For number which one? For number 2. Oh yeah, I'm gonna go ahead and I know Israel understands. I know. So you're saying this should be like 1. That way you have like 1 times 1 is 1. 1 times 1 is 1 instead of getting 1. Yes, and or charging, but I think you want more personal. So we're not like juggling, so if you want at 12, I'll be in, so just log in at. Okay, thank you, you're welcome. Thank you so much. Hope everything works out. Thank you. Okay, so where are we at? So this length, for me, I'm curious, is it actually 1 though? I'm curious about that. I know this length is 1. I actually don't remember if it was 2. Let's see. I mean, what we can do, you know what we can also do is like, imagine this is a triangle. Right, like just one of these is a triangle. Yeah, that's right. So the length is 1. Your height or whatever width is 1. So 1 times 1 and then divided by 2 is what? Yeah, so then we know that, I don't know if you're writing. I've already done it. So we know that just this little triangle right here is 0.5 feet squared. And then you can fill it. So it's basically like, I think this is not 1. That's why. That's probably, yeah, it's probably 0. No, wait. Not sure, but I do know if you did Pythagorean theorem, you can figure it out. I think okay. It's actually this. If you did Pythagorean theorem, that's the length of that side. Isn't that wild? 2 squared. The square root of 2, yeah, because I know if you do 1 squared plus 1 squared equals c squared. 1 squared is 1. 1 squared is 1. Yeah, so then you have the square root. So that length is that actually. So then the strategy here is to just imagine just one of these is a triangle, and then just get that area, and then you just times 4 to get the area. So try to type out that explanation. So I don't know how Israel did it. If you did it the triangle method, or you did it some other way, so I'm not exactly sure. But just as long as you can explain it. But we did the triangle method. Kind of best makes sense. Do I do it now? Like the triangle.
Yeah, what that's the tax.
That's right. Yeah, so we found 1 of them, and then it's basically times 4. Do I do this now? Yes. And basically, it might be hard if people are talking, but do you know how to whistle? Oh, no, never mind. So you can try singing and try holding a note. So if you want to go outside and, you can try that out. And once you think you've got one, if you could show me before you take your screenshot. Okay, let's see. Oh, there's two things in the chat. So let me see what's going on. Hi, y'all. So Juan finished. Okay, that's amazing. And Rebecca, not yet. So Rebecca, we actually still got to find your A, B, C, D. So we still got to find your B, C, and D. So not yet. So right now what you need to be doing is typing out the explanation for how we just got your A. So let me go to your mini file. I'll make sure that, yeah, so right here for you, Rebecca, right now, if you can type out what we just did right now to find how your A was 0.02. So explain how you got your A term right now. Perfect. And then let me just double check on you, AJ. Okay, 0.07. I think I agree with that. Let me look here. I think I agree with that. Awesome job. And if you could give me a little brief explanation on how you got that for AJ would be awesome. Yeah, you could type it right below here. If they like, I got my A term by, and just give me a brief explanation as well, just so that I understand that, that you understand how we got it. So those are the next tasks for.
Wait, Miss Sedano,
Yes.
it doesn't, the graph doesn't look the same as my wavelength.
Which graph? This one here?
Yeah, the one from Desmos, it looks different. I haven't put it on yet, but I can,
Okay, so yeah, it's gonna, we're gonna have to make sure. So basically, does the amplitude look different? Like, does the 0.0, does this one here look different? Or is basically the other parts of it?
the amplitude, I believe, the 0.07.
Do you have it? Like, can you share your screen?
I'm on my phone, but I'll just take a screenshot and put it on the
Yeah,
document.
yeah, go ahead and do that, and then we could take a look. I do know we want to double check, and I forget if we found this together or not yesterday. Oh, that looks perfect. Perfection. I mean, there's little squiggles on it, but that's fine. So now we're gonna measure the period. Do you remember what one period is of a wave?
Like just
Something like that, yeah. So there's a strategy for how to figure out the period. You measure from peak to peak. So if you could, yeah. So basically, if you can move those purple lines to be right on top of two peaks. And then that's gonna, and then that's gonna tell you one period, and then take your screenshot from there. So yeah, I don't remember about this B term, if we did that together or not. But we definitely want to check in on how you got your B as well. I forget. Did we talk about that yesterday, AJ, or no? I forget who I found B with yesterday.
I don't think we did.
Okay, so we're gonna have to, so Rebecca and you are gonna be done with your A term. Then next we'll talk about how to get B together, and then y'all can take a look at that.
Wait, is my B term the 7.66?
I forget, like I don't remember if we did that one together or not.
I think we did.
Okay, we could double check it too, because if we did do it together, I wonder if you have your work from that. If you want to type it out so I could kind of review it. That would be awesome.
All right.
Yeah, but if you don't, we could just redo it, and that's okay. Yes, perfect. You're gonna take your screenshot. Okay, next, Jasmine, right? So your computer's ready. Okay, so where we left off. So you said we want to choose sine. So remember, sine starts at the midline and then goes up. So I'm gonna redraw your midline right here. It's in red. And your wave starts at the midline and then goes up right here. So let me just make a little dark dot there. So see how it shifted a little bit to the right. The starting point shifted a bit. Now me and you, or you, because I'm really bad at estimates too, but we got to estimate now how far this shifted over. It's very small. It's a very small number. It shifted very tiny. So this is 1.1. What can we say this is? 0.1 or 0.2.
0. This doesn't go through 0.0, so 0.0.
Any estimate could work. I'll just take whatever, I'll do 0.01, so like super, super small. Because this is 1.1, this is 0.5. So the scaling is actually larger on the x-axis than it is in here. So this is 0.5 right here. So midway, about 0.5. So basically we're saying like about how much is this? Let's see, halfway between 0 and 0.5 is 0.25, I think. But that's a little bit larger than that. So there's 0.25. So what will we say then? Should be just a number slightly less than 0.25. That works. Let's do 0.23. So we're saying that your sine function shifted, phase shifted to the right by 0.23. I think that's a pretty good estimate. Okay, but that's not our C term. That's just initially finding a phase shift. If you go back to the big ideas packet, there is a phase shift formula. And then let me know what the formula is, and then maybe we can do it on the board. That would be easiest for me.
I have to convert this to seconds.
That's right. Do you know how to do that, or do you need some support? So, yeah, perfect. You're reading the question there. And then while Jasmine is looking up for the phase shift formula, let me ask you, do you know how many milliseconds are in a second? I don't either. Can we try to Google it? Because that's what I do too. Then let me know what your what you got to as your period. Yeah, perfect. So in 1 second, this is 1 second, not a 15, it's a S. There are 1,000 milliseconds. Perfect. So we're going to use this to multiply and change the unit. So what was your millisecond period?
3.62.
3.62 milliseconds. Oops. There we go. Is there a unit that cancels out, or what unit is the same here? Second. This one or the millisecond?
Millisecond.
Millisecond. So usually whatever is the same cancels out. And then basically that's why in the end you're going to be left over with seconds, because that's going to get canceled out. So awesome. So we have 3.62 times 1. Basically that's just 3.62 seconds. Divided by, this didn't go away, so we still got to divide it by 1,000. So basically you're going to be done once you divide 3.62 divided by 1,000, and then we'll see how many seconds. It's going to be very small seconds.
It's 0.000.
0.2. Like this.
Yeah.
So there's your seconds conversion. So then now your job is to go ahead and just either you can type out like the way the math worked out, or verbally explain what we just did. Okay, and then for Jasmine, were you able to find the phase shift formula?
Yeah.
Cool. Let me stop my share so we could see how to use the phase shift formula. And let me see if I could spotlight this is so weird. Okay, let me just get rid of this. Why don't you kind of blink boards? That's nice. Well, I wonder if I could just delete this. Make this schedule. That way I don't have to turn off my board. I'll just do this. That way for anyone else who needs to see how to do face shift and take a look. I know, beautiful schedule. Well, that's okay, today was the last day of the schedule, so. I'm gonna turn off my audio from this one and turn on from the iPad. It's so confusing. Hello? Hello? Okay, so it's working now. Okay, so right now what I'm doing for those at home is I'm trying to show us how to do the phase shift. So that's C term. If you go to big ideas number 9, there's a formulas list, right? There's amplitude, there's the period one, and in orange, you see the phase shift formula. So this is for functions that have phase shift. So I'm gonna help Jasmine's with this. Then I'm gonna check in with Rebecca and AJ on their progress. Okay, there we go. So go ahead and tell me what you got for the phase shift formula.
So pollution is like P dot as equals C over V.
All right, perfect. And we just found your phase shift. Do you remember what number that was?
So that would be 0.23.
Perfect. So notice that all I did is I just substituted what your phase shift was into the formula. Is there anything else you know? Do you know C or do you know B in this formula?
For V, I know that would be 4.33.
Yeah, you have your B already, so it's 4.33. Perfect. Okay. Our goal is we got to solve for your C. So we set this up. What are some ideas? This actually looks very similar to how we did B.
So V. No, it's a picture. So we can put like one over one, right?
Yeah, you put this guy over 1. And then what do we do after that?
Then we like cross multiply.
Perfect. We're going to cross multiply. That's usually the strategy when you have fraction equal to fraction. So then what you want to multiply is 0.23 times 4.33. Then we're going to do 1 times C. 1 times C is just going to be C. And then I'll wait to see what you get for your C there.
Which would be 0.99.
I guess there's your C term. So that's how you would find your C using your phase shift formula. Also, I know it's kind of not in your big ideas packet, but your D term is basically the Y value of where your midline is at.
So I find that too.
You actually know where your midline is at. I think from when we did amplitude,
Oh, that'd be like 1.45, right?
I forget. No, I think it was, I don't know if you wrote it down. I don't know
I
if
think
yours
I did.
was 0.05, not sure, but it's like where that midline intersected your Y axis. That's gonna be your D. And for anyone watching, that's how we find D.
I can be muted.
Oh my goodness, I'm muted.
Yeah, I feel like. Oh wait, I don't know.
I don't know.
It looks mute on your laptop.
Yeah, it's mute on the laptop, so I don't know if folks at home can hear me.
I'm not here.
Yes, we can.
Oh, you can?
Oh, okay.
Bye, Rebecca.
Hi.
Okay, great. So y'all can hear. So I just did an example of how we do phase shift and the D. Maybe AJ, Rebecca, y'all know what your D term is because it's basically the Y value of where your midline is intersecting. But we could also get support on that once we get there. Yeah.
So why would we like,
Oh my gosh, somebody started drawing ratio. I did not hear that because I had my computer muted.
because this is 1.45, right? Or the,
It's actually, you know, the midline's right here.
so it'd be 0.05.
Yeah, so perfect, that's your B term right there. Okay, cool, so then your job is gonna be to now go ahead and type this up, I'll leave this up there. Oh, and. Cool, how'd you get that frequency? Oh, awesome, so you did 1 divided by your frequency, your period in seconds or milliseconds? Okay. 1 divided by milliseconds. Okay, perfect. So I think if we go back to big ideas, it said frequency is when you divide it by your seconds conversion. So almost there. No, you did. Oh, you got it. You did it by your seconds conversion. Perfect. That would be awesome. Yeah, could you just give us a detail like what you did and all that? That would be awesome. And we got, I'm confused, me too. Okay, y'all, I'll be checking in with this group. I need to check in with AP Health. So we're gonna jump into where y'all are confused, but for AJ and Rebecca, did y'all finish up explaining how you got your amplitude? Yeah, Rebecca did. How about you, AJ?
No, not yet.
Okay. Hopefully y'all can hear me because I know it's actually the iPad that's doing the sound. But, okay, if you can work on that, or do you need support on typing up the explanation? Or you just need to work on
Just need to work on that.
that? Okay, cool. So I'm gonna be checking in with AP Calc, because you've been just there, and then I'll be back to pre-calc, okay? All right, so let's see. Wishing I had another board. Let me just take this one. No, maybe it's actually don't need a projector. Okay, cool. So then, all right, so number 1, number 2, and number 4 for Israel and Viviana, you all good for those 3. Cool. So if you look at the rubric, you all are at developing. You have at least 30. So you're at a developing score, which is cool. So y'all did that on your own. That's of course, that's amazing. So for number 3, wait, Israel, you had an attempt, did you?
Oh, no.
Oh, no, okay, I thought you did. Okay, number 3 looks like a weird shape. You cannot use geometry because it has like a curvy looking thing. But what you do have is a function. So this is the part where we gotta use calculus. We're gonna be using the FTC theorem. So let's look at the function. Okay, what stuff do y'all remember about FTC? Like anything. It could be any little part of it. We have no nothing. Let's see if Viviana, are you like also pulling stuff? Or what's something you remember about finding area under curve? Like the bars and stuff? Oh, like doing Riemann sums? So like if you were to graph it, I know there's something like this. Like a weird shape. So you could do, you're saying you could do Riemann sums. You could, but wouldn't that take you forever? Like you could do that. That is a possibility. But, and that's a good thing that y'all brought up, but we could also use the fundamental theorem Fundamental theorem is when we have this, y'all remember this thing? Yeah. Integral symbol, so that symbol represents finding area under curve. And actually, what we're gonna do is actually the strategy that me and Viviana did for number 2. We're actually just gonna focus. We have this, oops, and we have that funny looking graph that looks like, I don't know what this looks like. It's supposed to be all even, right? Just imagine that's all even. And what we're actually gonna do is we're just gonna focus on the first question. Because if we get the area of this, and all we gotta do is multiply by 4. So that's gonna be the strategy. And we know, and if you look in your graph, we know that this starts at 0 and ends at 1. So what that means when you're setting up the integral is that it's going to start from 0 and end at 1. So we know kind of like where to start and where to end. So let's see if there's any questions coming up or if everything's okay so far. Okay. Usually though, when you write your integral, you just go ahead and write down your function, and we usually don't write y equals. We just bring down the function. So basically what the symbolism is telling us is saying, I'm gonna find the area under the curve from 0 to 1 on the x-axis of this function. That's what this is telling us to do. Okay, so I wonder, after we have this set up, what do y'all remember about what we do next, if y'all remember anything from that part?
Like, I know you don't break down the dx.
You don't bring down the dx, that's true, that does not come down. And then you said simplify, there is gonna be simplification happening, for sure.
You don't fill in the x, right?
You don't put the what?
Like, you don't plug in x, right?
We will be plugging in x, so there is some x, if you remember, there was like top minus bottom, remember that part a little bit? Okay.
Oh, isn't it the x plus n over n or something like that?
Yes, that's the antiderivative. Yeah, so the integral, basically there's the rules. If you have some x to the n power, the antiderivative is x to the n plus 1 divided by n plus 1. That's the rule we're going to use. So the first step here is find the antiderivative. So that's going to be the next step. And basically we got to find the antiderivative of 3 things. This, and this. So for this one, the constant 1, it's kind of hard to apply this rule because it doesn't have an x. But basically what we have to know is that the antiderivative of 1 is just close, it's just x. And the reason for that, that's your antiderivative. The reason for that is because if I take the derivative of x, that's 1. So it should work backwards. So this one is just something we have to know. Antiderivative of 1 is x. I'm going to bring down that plus, and now we can apply that rule here, because there's an imaginary x to the first power. What do y'all think would be the antiderivative of that?
What? Oh, wait, no.
Using that rule there, because we have x to the first, so what's going to happen to that? Well, what do we do? So here's, it's like we have this. Instead of n, we know it's a 1, right? So basically, what's that telling me is going to happen? What's 1 plus 1 for that? So for example, and then what's at the bottom? That's actually how you do it. That's it. You just add 1 to the exponent and then divide it by that very same number. And that's how you use the rule. So usually I like bringing this divided by 2 in the front, like 1/2, but whatever makes you all comfortable, I could just keep it like this. So when I do it, it kind of confuses folks. Okay, so So now let's prepare for this next one. So -2, that's just gonna come down. But we still gotta find the antiderivative of this x squared. So let's go ahead and apply the rule now. So instead of a 1, it's now x squared that we're trying to find the antiderivative of. So what does that become? Perfect. There is your antiderivative. So that's step 1. Let's solve this. Step 2, then we're gonna go to simplify. So let's just make this look nicer.
Can I get one?
Oh, yeah, for sure. And this is how I'm gonna simplify this, so I'm just gonna do x plus 1/2 x squared minus 2/3 x to the 5th. So basically I just pulled out the fractions and moved it to the front. Just makes it easier. Oh, well, this is x plus 1/2 x squared minus 2/3 x to the 3rd power. For this one? So it's x plus 1/2 x squared minus 2/3 x to the 3rd power. Sorry, I guess your brain is not that good. So we're here, so I just simplified it. Then we're gonna do the plugging in and subtracting rule into this antiderivative. So try that out. I'm gonna check for here with J-Lo. That one, yeah, so we can get you started, so I know, AJ and Rebecca and everyone else that's started, let me get your weight again. Perfect, so yours starts kind of like in the middle, and then goes up, right? So, let's put your big ideas packet. And let's go to big idea 8. Perfect, right there. So we first gotta decide if you're using sine or cosine. Take a look, sine starts like at its midline and then goes up. Yeah, perfect, you know which one to use, so we're gonna use sine, yours is perfect, this one was, oh, yours actually doesn't have a phase shift. So that's gonna be nice. So if now we can go to big idea 9. That's what we're gonna try to do next. So this is what you wanna type out, so this is your parent function. You could also type out why you just chose sine right now, to give us a little background, and then you're gonna find the A, B, C, and D terms. In the same kind of way that's shown there. Yes, that's right. Okay, y'all, so I'm gonna go ahead and get you started in the fundamental theorem, and then I'm gonna go back to pre-calc. So after this, I'm gonna now switch to black. Now it's when we're gonna do this part, when we do f of b minus f of a. The capital X represent antiderivative, which we already found. B means I'm gonna plug in b. This is b, and this is my a. And we're gonna subtract. So the hard part is y'all are gonna try to have to agree on an answer, because a lot of people mess up with the algebra prep. So we're gonna first plug in b. So what? Notice I'm just gonna plug in 1 into this function. So that's me just plugging in 1 into the antiderivative. And I feel free to move up with my writing this time. I think I have to erase this because it's too big. So I'm now gonna subtract. And I'm gonna plug in 0. Yeah, feel free. Plug in 0. Now your job is to figure out what that is. And try to come up to an agreement, y'all are free to like work together on it.
I'm gonna go to the back.
Okay, so I'm gonna go ahead and turn off the audio here. All right, everyone, I am back. So let's go ahead and talk about the confusion part. Okay, so AJ said phase shift, pretty sure it's 0. Let me go ahead and check out where y'all are at. So let me go back. And just move this. So this one is Rebecca's. Rebecca, you wrote down the A. Perfect. And then for AJ, you got your 0.07. Okay, and you got your period. I mean, it sounds like we did have to subtract the period. I had to divide 2 pi by 0.82. So we did do your, yeah, I think we did do that together then to get your period. So you're set. You were asking about phase shift then, AJ, right?
Yeah.
And since you're on your phone, you're not able to share your graph, right? Sorry if you're in the chat.
The graph on there is for the new
Just
equation
for
that I came up
AJ, if
with.
you're there.
Can you hear me? Hello?
Okay, let me know when you come back. Or can you all hear me? Rebecca, are you there?
Yeah.
Oh my gosh, were you all responding? I'm so sorry. It's because I just realized my computer was muted. Oh my gosh, I'm sorry, AJ. Anyway,
It's fine.
okay. Sorry, my bad. So I think your B looks great. And so you were asking about your C, right? Your phase shift. And you said you're pretty sure it's 0. I think yours is 0 too. Can you explain why?
There's not a shift horizontally.
And you're choosing sine or cosine?
Cosine.
Cosine. So cosine, so right here I'm projecting our big ideas, right? And this is big idea 8. So notice how cosine starts at the maximum on the y-axis and then it goes down. Whereas sine starts at the midline and then goes up. So let me go back to yours and let's see how yours starts. Yours actually looks like it's starting around the midline and going up. So would you say yours is more like sine or cosine actually?
Probably sine.
Yeah, so sine. So sine, if you use sine, you don't have a phase shift. Now, if you want to use cosine, there will be a phase shift because your first maximum, it starts like I don't know if you can see my mouse, but your first maximum starts right here. If you were to use cosine, which does have a very small shift like that. Whereas if you stick with sine, sine starts right here at the midline and goes up. You have no phase shift if you stick with sine. So yes, let's stick with sine and you have no phase shift, but now you want to kind of just explain why you don't have a phase shift. Again, if you're comparing this to the parent functions, the fact that sine starts at the midline and then goes up, just like shown here. Yours is doing the same thing. It's starting on the y-axis on the midline and then going up. That's why you don't have a phase shift. Did that part make sense for you?
Yeah, but I don't. What about the vertical shift too? 'Cause I don't.
Okay, vertical shift. So I don't know if you heard what I told Jasmine when I was in the iPad. Were you able to hear what I told her or no?
I think I wasn't paying attention.
Okay, that's okay. No problem. So right now, I just stopped my share. Do you see the board work?
Yeah.
What does it say about the D term?
Y value where your midline is at.
Yeah, so basically, let's go back to your graph. Where was your midline at?
It was
Let's see if you mentioned, no, you didn't mention it anywhere. So It's basically
Alright.
where is this midline intersecting? Let me just draw
I think
it.
it's 0.5 or
Close.
0.05.
Yeah, there we go. Your midline is at 0.05, around right in between here, right? That is your D term. It's basically the Y term of where your midline is intersecting it.
All right.
0.05. So perfect. And then it looks like you have your ABCD now. And again, so I know you have cosine right here. You're going to switch that to sine. So it looks like sine was a better candidate for your wave. Maybe back.
Miss Sedano, I think you're on mute.
Are you talking, Miss Adano?
Yeah, I am talking, but I was talking to another student. So I'll be back with you in a second. Where was your midline? We said 0.05. Yeah. So then if I want to find kind of like the distance between the two, what could I do? Subtract. Yeah, and that's going to give you your amplitude. So basically, we'll subtract, and that's going to be your A. All right, so I'm back, y'all. Oh, okay. Rebecca needs to go to the. Wait, did you go yet, or are you back? Oh, yes. The next thing you want to do is you want to go on Desmos and put your equation in there. So go to desmos.com. Creating the girl. No, that's a desmos.com. I don't know. Will we do the same, like, starting with the fundamental theorem for the other ones? Which ones? For that. So actually those, we don't know, we don't have the rules for them. So actually for those, you're gonna be using Riemann sums. Now, if you actually do Riemann sums, it's gonna take you a long while, so I'm gonna send you guys a tool to use instead. So I'm gonna send it to your email. Let me do that now very quickly. Give me a sec, y'all. I gotta send something super quick. So it's gonna be a tool. It's gonna make it very nice for y'all. Let's see. Okay, I sent it. So that's gonna help you for 5 and 6. And then all y'all gotta do is type it out and explain. I hope it makes sense, but feel free to like talk about it if it doesn't. Okay, so Rebecca, I wonder if you're back. Are you back or should I check in with AJ? Okay, let me know. And then for AJ, where are you at? Sorry. Okay, you went and put in your equation. Okay, so what are your thoughts about this one? Do you think this looks like your wave or no?
Not really, but I mean,
Okay, can I go ahead and join you and try to put that in too?
yeah.
Okay, so then. For the period? Yes, that's correct. And then for Jasmine, I'm gonna project my board once more now, so I'm gonna erase that, so that you can see what I mean about going to Desmond, because that's what AJ's, initial AJ's. I'm gonna delete this, y'all got this already for Viviana and Israel?
Oh, yeah.
Okay. Yes. Okay, don't forget that y'all multiply the answer by 4 for number.
Oh, yeah.
Okay,
I got, we got that 0.8.
84.
that's what y'all got, 0.84.
for the one.
And then both of you got it, so in agreement, I think it should be right. I'll check it though, but, I mean, other than that, it sounds right because the other ones were like, the square was 1, the diamond was like, it seems around the range.
Yeah, because that when we multiplied it all by 4, it was 3.3.
Okay. That sounds right. What was that?
I don't have a pen. I don't have a pencil, unfortunately, but I did have some graph. If you ask it. Here's some penning. You're welcome.
So I'm waiting for this to, oops,
Turn on now.
I was trying to turn it on. So I'm just turning this on, AJ, so I could then check out your graph and show everyone, like, once you're done with your ABC, going to Desmos and putting in that screenshot. Okay, turning on. So I'm gonna also go to desmos.com and just put in that very same equation that you found. So desmos.com. Let me join, graphing calculator. So this is actually how I like to start it. And then this is also for Rebecca too, if you already want to get a start, but you're not going to be done yet because we still need to find your BCD. But basically you're going to type out your parent function. So a lot of us have sine, some have cosine. So it's going to be A sine bx minus c. So this is me typing out that parent function plus d. And then notice how it says add slider. I'm just going to do all. And then you just get, automatically, it just chooses 1 for everything. So now let me go ahead and put what AG had found for his A. So 0.07. Your B was, let me go back to your thing, 7.66. Your C, we said there was no phase shift for you. And your D was, let's go back. Sorry, what was your D? 0.05. It looks the same like how AJ's is looking, right? So if we compare AJ's graph, though, it does look different. So going back to the original sound wave, looks like you see, it looks taller. The waves look more taller. So then what I'm going to do is I'm going to look at the scaling here. So notice how the y-axis was scaled. Its largest y value was 0.3. The lowest was negative 0.3. Then on the x-axis, the highest x value it went to was 20.9. So what I'm going to do is I'm going to just adjust the scaling by going to this little wrench. So remember, my x went to like 20.9, and it also started at 0. So I'm adjusting the x-axis right here on the screen. The y, remember the highest y was 0.3. The lowest y was negative 0.3. Now notice how it looks better. So this looks a little bit more like your wave. Let's compare it. Doesn't look precisely like it. It kind of looks a little bit sharper, so it's not gonna be perfect. But that's like a better representation of your wave, and how I got the improved version was by fixing the scaling right here. So that's for you, AJ. And then, by the way, in number 3, it says, does it look like your original wave or not? Just give me a little brief explanation as to if this does or not, and what you could do to make it better or something if you think of anything.
All right. Oh, can you keep up the little tool thing so I can like put it in Desmos real quick?
Yeah, for sure. Who's, oh,
This one's the number 5, right? So number 5, so basically this function I shared with y'all is just for e to the x. So the function you want to type in there is this. So you want to fix the actual function. Likewise, I wonder if you were able to, yeah, so the function, you could change the function to whatever you want. Yeah.
When you're doing this is what my number is.
That's right.
And then I divide each side by that.
That's correct. Yeah, you got it. Awesome. Cool, isn't it? Okay.
I got. So this would be my B.
That would be your fee, that's right. 2 pi divided by 3.62. Can I double check it?
Yeah.
This is how I would double check it. And let's see, I will do 2, and then I'm gonna do, I hope pi works here. Oh my gosh, pi? Dang. What is it? Sorry. 2, control E.
Just as
Okay, so 2 pi. And then n hit n equals. Wait, what? This 2 pi should be like 6 point something. I don't know why the icon is that. So that's pi times 2.
2 times 2.
Wait, was there a 2 pi? Yeah, there is, okay. Try it out, let's see. And I'm just gonna put pi then, so 2 pi divided by 3.62.
Yeah, that's right. So this one.
Yeah, I don't know. Sometimes my iPhone is weird. The oh, there's also one there. I wonder if we could check it there. I'm forgetting because we turn it on right here. And we just clear that up here, and then 2, and then pi is in blue, so we're gonna push second pi, then put divided by. Okay. So yeah, it's probably just the iPhone thing, but you got the steps down. You're welcome. Were you able to recreate your decimal?
Do I put just 1.73? So I'll just put 1.73.
For your B, yeah, you could round it to 1.7. I would round it to 1.74 since it's next to a 5 there.
Oh, right.
Let me look at your. And how does your original one look like again? Does it look like your original sound? It looks more elongated, huh?
I'm not very good at
That's it, the rest of it. And yours was, we did choose sign. Yeah, we did. The shift looks good. Let me go ahead and see your little wrench. Here, I think I know. Make it look more better. So I'm gonna fix this the same way I did with AJ's. So I'm just gonna fix the window, because I remember this one was at 20.9. And it started at 0. And then the Y, if you remember, the Y went up to 0.3. Like the height. And then the lowest is at negative 0. So that is, and let's now compare. That's better. It's just a scan, it was just a window, fixing up the window, so that's perfect. That's right. And then you're gonna just give us a little brief, like, does it look like exactly? You're gonna probably say a little bit, because you know how these have little kind of, I don't know how you would describe those little dips there. But that doesn't have the dips. Yeah, you can add the photo like right below, and then you can add that like a little analysis, like it's not exactly a fit, but it actually looks pretty good. Okay, thank you. You're welcome. Okay, cool. So now, great. So let me know, AJ, what you need some support on. And I see you, Alasia, you're in here. Let me know where you're at so I could check in with you. And then for Rebecca, we still need to find your B term.
So I'm gonna go ahead and jump to Rebecca's mini final. And AJ, is it okay if I take this out?
Yeah, it's fine.
Awesome. So I'm gonna go ahead and get out of here. Actually, maybe I'm gonna keep this because I know for Angela, so, oh my gosh, I'm so sorry. I know for Rebecca that we're gonna be using this again. And for you, Rebecca, what was your amplitude? X out of Jasmine's. I forgot. Oh, we said it was gonna be 0.02. So yours is gonna be 0.02. Sorry, the A went all the way down here. I don't know how to move it up. So there's your A. We don't see anything yet because it's up here. But we need to fix what your B is, your C, and your D. So that's what we're gonna do next. Okay, we'll go here. Okay, so in order to find your B term, and this is a question for you, Rebecca, I'm gonna go back to our big ideas packet. We're gonna go to big idea number 9. Now, take a look here at this screenshot. So we've done this before. So we have A, in blue you have the B term. What is the formula that we need to find B? If you could point it out from this screenshot.
The blue part, the pie.
The blue part, yeah. What is the formula that we need to find that B? It is in blue.
P equals 2 pi
Yeah, 2 pi over,
over 1.
I wonder if you see, I don't know if you're able to see this actually, but it's right here. So close. It's a period is equal to 2 pi over B. So that's the formula that we're going to need to use. And we're going to have to go through these steps here that starts in blue to get the B term. So we're going to be doing the same steps. And your B term basically is strongly related to whatever the period of your wave is. So I'm going to go back to your graph, and we're going to write down that function. Sorry, the formula. Oh yeah, and then I see that AJ, you need some support on number 4. So number 4, we'll get to that. Let me just get Rebecca started on this one, and we'll talk about number 4 for those who are there. So here's the formula that we need. So Rebecca, can you remind me what was your P? You found your P in number 2. Or what was your period is basically what I was asking actually. What was your period in milliseconds?
In milliseconds, it was 0.00.
0 point. I didn't catch the last part. Oh, were you saying this? Were you saying this number right here?
Yeah, but that's in seconds. It would be the top one on the screenshot.
That's right. Okay, 3.72.
Mm-hmm.
Okay, let's do that one. So, and I like the milliseconds actually. So basically instead of P, we're gonna write 3.72. So actually, I think I want to, it's hard to do this on screen, so I'm going to jump onto the iPad. So let me stop my share. You see the iPad right now, right?
Yeah.
Okay, my voice though is in my camera. I don't know, it's kind of a hassle to, I hope you can hear me. So, let's see. Okay, remind me, what was your period again?
It is 3.72.
And that is going to be So that's our setup, right? So if you go to the big ideas packet, big idea number 9, right? You see what happens after this step? Something should happen after this step. In order for us to solve for B, we're trying to get this B by itself. Now there's a glare.
Yeah.
I don't remember what I was projecting anyway. Do you want me to project the big ideas so you can look and see? So big ideas packet right here. So same steps. We identified the period. Yours was 3.72. Then we plugged it into the formula. Then what happens next?
Then you have to do 2 pi equals 2 pi and the b, I guess.
Yeah, and do you see what these red letters say?
Let me check mine. It says cross multiply.
Yes, so that's what we're gonna be doing to solve for B. Learn how to cross multiply. And I don't know if you noticed that, now I'm back in the iPad, if you could see. So I don't know if you noticed that we have to put this number over 1 for us to cross multiply. So that's what we're gonna do, and let's cross multiply to find what your B is. So here, 1 is gonna multiply to 2 pi. So 3.72 times B. You have 1 times 2 pi. Okay, so we're at this step, right? Your goal is to get the B by itself. So, what can I do to get B by itself? It's something I have to do to both sides. If you look at the big ideas packet, it doesn't really show exactly what happened there. The second to last step.
You cross out the pi, right?
The pies do end up, but in the big ideas, oh yeah, let me stop my share because that's confusing. Yeah, in the big ideas, the pie did disappear, right? But it was a little bit hard to see what happened there, but actually what's happening is we want to get rid of this number that's next to the B. So we're going to actually divide both sides. So we're going to divide both sides by that number, the 3.72. And then you're going to see why this works. Dividing is going to work because 3.72 divided by 3.72 is 1.
Mm-hmm.
And then 1 times B is just basically B. So basically your B is this. So if you could go on a calculator and tell me what you get, and I'll check it for you, but what's 2 pi divided by 3.72? That's going to be your B. So let me know what you get once you're there, then I'll check for you. That's basically your B though.
I got a really long number.
What'd you get?
One. Wait, let me take it out. 1.689 028308.
Let me check if that's what I get. Yes, I got the same thing. So I'm back now on my main screen. So I have no idea what, like, I'm like wondering what. Oh, okay, I'm like, what?
I think I should rejoin.
It's okay, you don't, I mean, it's not necessary, I'm just hoping, I don't know how. Yes, and I'll go to you, so that's exactly what I got, Rebecca. So go ahead and just now, your job is to type out how. And then I'm gonna jump in with AJ to figure out how to do number 4. So we just explained it, so just type out how. I hope the board, Rebecca, when I did the board work, were you able to see it big?
Can you stop screen recording so I could take a screenshot of the board, please?
Yeah, you see it now?
Yeah.
Okay.
Thank you.
Okay, so we'll talk about number 4. What was your frequency? Remember we calculated that from question number 2. Like forward splitting, it was in hertz. Question number 2. There we go. You got 600. Wait, what's that? 89.65 hertz. That's your frequency. So it's like you're right. The sound frequency, yes.
And then do it just play like that.
Yeah, you're gonna play it, and then we're gonna mess with it though, to try to make it sound more like your actual sound. Cause I remember we tested it right before, and I was like, it can kind of sound like this, I'm gonna make me forget. And then we're gonna turn on the volume. And then the volume's down there, we know how it says off. Cool, so then now you're gonna remember like the sound you made, and if it doesn't sound perfect, like, or more like close to the sound, you can play around with the harmonics, just mess with them. Or you can even play around with these buttons and see what happens to your sound. And then once you're satisfied with whatever you got, take a screenshot of your settings, just a whole screenshot of what you have there, and then just talk about how if you were, if it matched or not the sound. Awesome. Now I'm just gonna talk about that right now. Oh, PJ just came in. Okay, welcome back. So Rebecca, you got that screenshot?
Yes, I am typing up my explanation right now.
Perfect. I'm gonna go ahead and now take out the board spotlight. What? I don't know what I've done. Remove spotlight. There we go. Now I'm going to project my screen. So there was questions about number 4. So let's see what number 4 is about. So I'm going to go to AJ's. So for question number 4, it says, it gives a bunch of instructions. It says you can play a synthesized sound, same pitch. Oh, wait, let's see, sorry. Oh, Jayla, you're not able to see, huh? Let me project this. That's okay, I can project it too. I'm like turning off and on. I'm like, it's crazy. I don't know how we're gonna do this next year too. With a full class, that will be interesting. All right, let me also erase this. Okay, cool. So there's a bunch of instructions, but you're being asked to play synthesized sound of the same pitch. So that means the pitch is gonna match. It's not gonna be the same sound you made though. It says enter the frequency of your sound, and everyone found your frequency. Actually, if you go back to number 2, remember you found your frequency. So this was AJ, your frequency, super high frequency. And so once you have your frequency, you could copy and paste it onto the applet. So let's open up the applet and let's do that. So once you get onto the applet, the frequency is already set to 440. So we're gonna switch that to whatever your frequency was. So this was a humongous frequency, dang, 1,219. We're gonna go here. So I went ahead and just pasted your frequency and we're gonna hit play. This might hurt though because this looks like it's gonna be a high frequency noise. Well, it doesn't hurt that much. So then you're gonna now compare, does that sound like it's the same pitch as the sound that you made? Let me turn that off. But basically what you can do, if it does not sound that great, like it doesn't sound like a good match, you're gonna play around with the harmonics or over here. Take a look at how we can do that. So I'm just playing with the harmonics. Or you could also click. So yeah, you're basically gonna mess with the harmonics, or you could try any of these. Once you're satisfied, like, okay, this is the closest I can get, take a whole screenshot and put that in for number 4. Once you do that, right, you're gonna go back to your number 4 and just finish answering the questions. There's just 2 questions for you after you go ahead and put your screenshot. How is the sound similar or different from your original sound? And a question is, can you do anything else to make it sound like the original? And you could be totally honest here. So it's more like reflection. Can't be. What was it? Oh, okay. Do you remember what was the sound you made? Oh my gosh. Okay.
I know it was a vowel, it was a vowel.
Okay, so singing a vowel. You could just type out what you did. Like I sung out a vowel. That's okay. And if you remember which vowel, that's all right. Okay, cool. So then for AJ and anyone else on number 4, let me know if that was pretty clear and what to do there. And then basically after you're done with number 4, number 5 is again pretty open-ended reflection. Basically, you're just going to report to your engineer. Like again, you're envisioning that you're working at this company. You're going to say like how successful you were in recreating your original sound. Was your sound a good or poor copy? And then you're being asked to think about what are some situations where it might be helpful to use like a fake sound as a replacement for the original. And again, this is pretty open-ended. Let me know if there's any more questions on 4 and 5. Other than that, like if you're ready to get started on that, then you're totally free to.
Oh, I understand what to do now.
Awesome. Okay, cool. And then I'll jump back to yours, Rebecca, for your C in a second. Let me check in. I'll be back. Oh my gosh, nobody heard me. Oh, so Rebecca, I see that you're typing out your work. So I'll let me know when you're ready once you're done with that.
Okay. Thank you, Miss Elena. I did. I finished the explanation.
Hello. Hello, Rebecca.
Hello, I finished.
Okay, thank you for letting me know. So now we're trying to figure out your C term. So in order to figure out C term, and if we look back to Big Ideas packet, your C is an orange right here. It's about phase shift. There's a formula for it. Also, phase shift shows up in Big Idea number 8. It says it's a horizontal shift. So basically shifting side to side, left or right. And here are the parent functions. You have your sine parent function, you have your cosine. Sine starts at the midline on the y-axis and goes up. Cosine starts on the y-axis at the maximum and goes down. Let's see what your wave looks more like. So let me go back to yours. So yours kind of starts, it looks like it's almost nearly starting at the midline. I mean, would you say this is starting at the maximum or the midline? There's your midline again.
Midline is starting at the midline.
Yeah, rather than the maximum, right? It's not starting over here, right?
Yeah.
So when it's starting at the midline and going up, is that sine or cosine?
I do not remember.
Let's go back and see. So which one does that? Oops. Sorry. There we go. Oops, that's not it still. Okay, there we go. Here we go. So here's sine in yellow and here's cosine. So which one starts at the midline and goes up?
Sorry, my internet cut out. What?
Oh, my bad. So here's your sine in yellow and here's your cosine in blue. Which one starts at the midline and then goes up?
Wouldn't it be the yellow?
That's right. And what's the yellow? Sorry, I went out. What's the yellow one called?
Sine.
Yes. So we're going to do sine because yours also starts at the midline and goes up. So you're choosing sine. And sine, your parent function looks like this. So basically you found your A, you found your B, and we're trying to find C, and then your D, and then you'll be done. So your C is basically phase shift. So we're going to figure out if your function has a phase shift. And we do so by comparing it to the parent function of sine. Starts right here, goes up. Let's see what yours does. Where does it start? Well, yours also, would you say it also starts at the same location and goes up? Did this starting point shift?
I don't know. No, I think it does.
So let me go back. So here starts at midline, goes up on the y-axis, right? So if I go back to yours, on the y-axis, yours is also starting in the midline and going up. When that is happening, you don't have a phase shift. Yours is also starting at the same location. So what would you say if you have no phase shift? What would you say your C is then? So that's the question I put right here. So if you don't have a phase shift, what would you say your C value is?
0.
Yeah, it's gonna be 0. And now it's gonna be your job to explain that, what we just did right now, and why your phase shift is 0. Again, it's starting at the same location as the parent function for sine. If you look back at the big ideas. So same location because yours is also starting at the y-axis on the midline, and then going up, you have no phase shift, which is nice. This is kind of less work for you. So I'll let you type that out, and then we'll talk about your D term. Cool, and then let me know when you're ready. I'll be here.
Okay. Okay, I'm done.
All right, we're ready. I think I'm zoomed into your mini final. Okay, let's see. I like how you wrote phase shift. So it's a phase shift like this. It sounds funny, like a phase shift.
I'm terrible at spelling, so
Okay. I understood what you meant though, either way. Okay, so now it's your D term. Actually, so your D term, let me stop my share and let me reshare that. Oh no, it's gone. Never mind. I was gonna share what I had on the board about Z. It's gone. So your D term basically is the Y value of where your midline is at. Oh, let me go back here. We actually found your midline, remember? So what was that Y value of your midline again? I'm making it large.
0.05.
That's your D term. That's it. That is your D. So basically it's the Y value of where your midline is intersecting the Y axis. That is your D term. And that's all you got to type out. So now that we have all that, we'll be ready to go to Desmos and put your function in there and see how it looks like. Cool. Let me know when you're ready with that.
Miss Sedano, I'm finished with the final.
All right, so if you feel like you're ready, I mean, feel free to go ahead and submit, or do you want me to check out something, or you feel like you're good?
I already submitted it.
Okay, then you're good. Okay, cool. I'll look it over later, but I feel like you did, I mean, we were walking through it, so I think you're good. Thank you so much and congrats on turning in your mini final.
All right, bye, Miss Sedano.
Bye, thank you so much. See you guys. Bye. Enjoy your lunch. You're welcome. Okay, so it's me, Rebecca, and the iPad. That's like, I know the other day I was like, oh, I have 3 students. Oh, it's just the iPad locked in. Oh, I'm sorry. Okay, yay.
Yay!
Hey, you're doing great work. And at least it's making sense and all right.
Yeah, finally makes sense.
I know, and I bet you're even more tired because that shot really hurts.
I did my explanation for game. I think, I don't know if I did it right though.
Okay, sorry, my bad. Let me. Sorry, let me go back to your mini final. There we go. Okay. All right, perfect. All right, so now going to Desmos. Basically, you want to do exactly, I hope you have this open. But you're gonna go ahead and so I put in your A on my side. Can you tell me what your B is? And I'll just go ahead and type it here. What's your B value that we got?
my B value, I put it in the chat, like the number 169.
1 point what? Like,
1.689028330.
I get rounded, so I just put 1.689. That's okay. And what's your C? Oh, we said C was 0, right?
Yes,
And
and then D is 0.05.
okay, so this is your wave. But let's adjust the screen because go back. Yours looks like more stretched out, right? Like if we were to look. So I'm gonna adjust. Let me get out of here. Sorry. Okay. I'm gonna adjust the screen by going up to the little wrench. Because I remember the X value went up to 20.9. It started at 0. See, it's starting to look better. And I know the Y value, the highest Y was 0.3 and the lowest Y was negative 0.3. So there is your wave. Like that. See how it kind of, it very much resembles how yours looks like. I think that was pretty successful. Take a look. I mean, these look a little bit like taller, but other than that, they look pretty good. I think they look nice. So that is your function. If you want, you could take a screenshot of this here. And then that's pretty much, oh wait, well, before you're done with number, so take a screenshot and enter that in, but before that, just make sure you answer these questions. Does it look like your original sound? If not, what can you do to make it look better? So that's the last two questions to answer once you put in the screenshot. Let me know if that makes sense, Rebecca.
Can you go back to the Desmos so I could screenshot
Oh,
it?
yes, of course. There you go.
Thank you.
Welcome. All right, so then you know what to do for your next step for Rebecca.
If you answer the question, if it's similar or not, I say it is similar, right?
Sure. I mean, yeah, if according to your opinion, I mean, I feel like it's pretty good. So does it resemble your original sound? And it says, if not, can you transcript? And yeah, so basically, yeah, you're just answering that question. You're basically your opinion on it. I mean, I thought it's pretty good. Cool. Let me know once you're done with that. Yay. Thank you so much.
Okay, I did it.
And I made a 4-hour playlist on my, like, just listening to music and I'm tired of it.
I mean, desperate times come for desperate measures.
Yeah. I'm like, hey, gotta do what you gotta do. So, yes, humbling experience.
I feel like I wouldn't like to even that if I was with a mask off.
I love the shoes. I love them. I love. I need more like those.
I need to like breathe. For something.
All right, y'all. See you soon. Enjoy lunch. Okay, sorry, Rebecca. Hello. Okay, so did you pay attention when I talked about number 4 or no? So I could go over number 4.
I was writing my explanation, so no.
Okay, so that's okay. So let's talk about number 4. So number 4 is actually basically once you're done with number 3, the rest is like pretty much you testing if your sound was replicable or whatever. So for number 4, you're gonna go to the applet right here. Let me close up everything, by the way, so I don't have so much tabs open. Okay, and what we're gonna do is it has a set frequency already of 440. Let's see what that sounds like. Okay, cool. And this right here, this applet can only match the pitch. It can't really match everything else of the sound you made. But I'm gonna go up to number 2 because remember you calculated your frequency yesterday. You got this number. Do you remember?
That's my frequency?
Yeah, it says to get the frequency. So that was yesterday. Remember you used the formula 1 divided by P?
Oh.
So you found your frequency already. So I'm gonna take that, copy it, and I'm gonna go right here. And I'm just gonna put the same frequency right here. So there's your frequency. It's just copied there. Let's go ahead and first let me ask you, what was the sound that you made?
The initial one was snapping, like snapping my fingers.
Right. And that made the wave? For what did you do after? Like how'd you get the perfect wave? I don't know if you're able to hear me.
Can you hear me?
I can hear you now.
Okay. The first one was me snapping my fingers, and then the second one was me humming.
There we go. Okay, so humming. Let's go ahead and see if this sounds like it. So I'm going to turn on the volume. It kind of does sound like a hum, the pitch. So that's if I turn up the volume a bit. So what you're going to now do, so this is your sound, is you're going to play around with either the harmonics or up here. So take a look what I mean. No, that does not sound like a hum. Or let's go back. So this is the original noise, or you can play around with these here. Yeah, everyone. So then you can play around, so just play around with the harmonics here until you think it matches the sound that you made. Or it could be that you just like the original, the first one was the best choice, just the original sound. So then once you're done and you decide like what harmonics or if you're going to play with any of these, you're going to go ahead and take a screenshot. And then after you're done with your screenshot, you're going to finish answering these 2 questions right here. How do they sound similar and different? And can you do anything else to make it sound more like the original? So that's all you have to do after you do your screenshot. And you play around with the harmonics and try to make it match your sound. And then that's all you got to do for number 4. Does that make sense?
Yeah, I have to play with the sound to get a similar sound. Then I have to I have to screenshot it, and then I have to answer the question.
Perfect. And then since it's lunchtime, I'm going to be heading to lunch, taking a break. But for number 5, basically, once you're done at number 4, number 5 is basically like a reflection. So that's something you could totally do. It says, let's just imagine you're working at Sony, the sound company, You're gonna report your findings to the lead engineer. You're just gonna analyze how successful you were in recreating your original sound. So that's the first question. Second question, in what ways was your copy a good or poor copy? And what are some situations that it might be helpful to use your synthesized sound to replace something that was original? So that's pretty much it. It's pretty open-ended for number 5. Just make sure you answer each question. You pretty much can't be wrong with it. It's like a reflection.
I don't know how I would answer the last question.
What was that?
I wouldn't know how to answer the last question.
What are some situations where it might be helpful to use? So I've got different stuff. Someone said they could use it in, someone said that they could use it for auto tune, like you know how people when they sing, or sometimes you know how Siri can pick up our voice like with sound, and Siri can like respond with you know like it's not really a person talking, but it's Siri like recreating sound and making like a sentence. You know what I mean when I'm saying Siri?
Yeah.
Another thing is someone said they could use their sound to replace like an alarm system in a school because it sounded like less harsh to the ears, but it was still alarming. So there's like different things you could think of um, on how and why you would use your copy of your sound. You can even think about music or something. Um, yeah. I'm hoping that was kind of helpful, but you could pretty much think outside the box with that last question.
Yeah, I got an idea now. Thank you.
Okay, all right, you're welcome. I'm gonna go ahead and take a lunch break. So I'll see ya. Bye.
Bye.
Bye.